So we're going to be talking about the concept of the electric field. Um, to understand the electric field, we have the equation right here. An electric field is a vector. It's defined to be the charge emitting the electric field over the radius squared. And this equation represents basically the charge that is experiencing the electric field. This charge here is not the charge that is experiencing the electric field. This charge is a neighboring charge. So let's say that we have this charge here. The electric field it is going to experience is going to be the electric field emitted by this orange charge. So basically our equation for the electric field experienced by this red charge would be this. That charge there is the charge in the red guy's vicinity, which is the orange charge here. So whenever you see this equation, it means that there is an electric field experienced by a charge which comes from another charge. That Q in the equation is the source of the electric field. And then R just is the radius or the distance between the two charges. So basically, the more the radius increases, the electric field will get weaker. What does that mean? The further away this red charge is from the orange one, the weaker their interaction will be. Let's say we have Jupiter and we have the Earth. These are two planets. They both have a gravitational field. If the Earth and Jupiter are put very close together, maybe a centimeter away, let's say that's possible, then Jupiter will pull Earth towards it very strongly. However, if you put a distance of 1 billion light years between Jupiter and Earth, they will not experience any sort of force towards each other. So that's kind of the idea with the electric field here between the two charges. If they're infinitely far away from each other, then they won't be able to influence each other. They won't be able to force each other or pull each other towards... Yeah, they wouldn't be able to pull each other, nor would they be able to repel each other. However, if the source charge, the one in orange, is very strong, it has a massive charge, like plus 1 million or something, then the electric field experienced by this red guy will be even stronger, so even higher. So now that I've kind of explained the idea behind the equation and how we can sort of look at any equation and try to just imagine increasing the denominator, only the denominator, and kind of seeing that if you increase the denominator in this massive equation, or in any equation for that matter, the result will always get smaller. So in this case, if we crank up the radius to infinity, then the electric field will get weaker, like almost zero. But if we crank up the strength of the source charge to infinity, then the electric field is going to get very strong, infinitesimally strong. So whenever you hear, infinity, infinitesimally, this is already kind of hinting towards integrals and calculus, but don't worry, we're not getting into that in this video. Now, I'm going to kind of finish this video off with an analogy because I think it's kind of important. Let's say you have three guys or three charges. The charge in purple, the purple guy, the red guy, and the orange guy. They just went to the gym and now they're sweating. They've come back to the locker room. They're sweating and they're smelly. What each of these each of these three people notices is how horrible the other two smell. So if I was this purple guy and I've come back from the gym with the other two, I would smell the orange guy and I would be smelling the red guy, and that would have an impact on me. I will be complaining to them, hey, you guys smell horrible, you need to take a shower. And then, of course, from the red guy's perspective, he's going to be looking at me, the purple guy, and the orange guy, and he's going to be like, no, you guys smell, the two of you are sweaty and you're really smelly. So this red guy is only able to smell the other two people in the room, basically. And this purple guy, which is me, is only able to smell the other two people in the room, which is the red guy and the orange guy. And the same kind of applies for the orange guy as well. He's only able to smell me, the purple guy, I'm the purple guy, and he's only able to smell the red guy. The problem with with the three of us, basically, is that we're looking at everyone else and noticing bad things about them. We're not looking at ourselves and how bad we are, how badly we smell. Sorry, that's what I meant to say. We're not looking at ourselves and realizing that, oh, okay, I also smell bad. So that's kind of the idea with this equation and the electric field. Whenever a charge, like myself over here, I've circled myself, is around other charges, it will experience an electric field from them. So I was here and I'm noticing how smelly these other two guys are. I'm noticing their electric fields. This guy smells like vinegar, this guy smells like a banana, let's say, for example. So each of these electric fields are slightly maybe different. Maybe this guy is a bit more muscly or has a lot of bacteria in his body, and so he smells like, vinegar. Whereas this guy, he smells like a banana. Maybe he's eating healthy, and that's why his bacteria don't release that kind of smell. So that's pretty much it behind electric field. These equations are all about, oh, I am a charge. I am just a charge sitting somewhere here, and apparently I'm experiencing an electric field from some other source. It could be a charge, or it could also be a sheet, a metallic sheet that has a bunch of charges on it. Same idea. So I hope that kind of helps you understand kind of the conceptual idea behind the electric field, and have a nice day. So the main thing to understand about this is that if all human beings were charges, we would always notice things about each other. We wouldn't really be noticing things about ourselves. We wouldn't ever notice how we smell or what we're doing. We would only notice what others do and how they smell. And that's kind of the idea with, I guess, in the context of physics, that's just the idea here with electric fields. A charge will always notice that another charge is nearby. No wonder the guy stinks, right? Of course, how can I not notice him, right? But yeah, so that's kind of the idea.